So, welcome to AP Chemistry. Today is Tuesday, October the 13th. Okay? And I got many emails last night, late. Not just one, I got many, not just from one person. But yes, the person you are pointing to, which will remain unnamed, did send me an email as well, and she commented that she was a little confused on the calculations, that they seemed too easy. And the reality is that they were quite easy to do, but as typical of students of your caliber, you tend to overthink sometimes and talk yourself into circles. And so I just want to quickly kind of go over the lab. And by the way, if you, I'm going to want a hard copy of your lab.
Oh, okay.
I know you turned it in, so you can bring it, to the next class. It's just easier for me to grade the hard copy than it is to grade it off the.
You want the original, not.
Whichever one's perforated, but I believe the blue one is, the original is the one that's perforated. All right, so how were you supposed to do the calculation?
Very careful.
I don't know.
Okay, well, what was really the only calculation? What was the only thing you were trying to find?
Molarity.
The unknown concentration, the molarity, the concentration in terms of molarity of the unknown solution, right?
Yes.
So put the three answers together. So that's the only calculation. So how did we do that? There were three ways you could have done that. Okay? All get you to the same answer. The first one is you drew a graph. Now on our graph, it's going to be absorbance versus concentration. Which one goes on the X, which one goes on the Y? Concentration on the X. So does that make it the independent or dependent variable?
Independent, but we're changing.
Did you want the K3?
No.
Independent.
We took a quiz on that one.
So it's the Y that changes the graph.
Okay? Yeah, so the independent variable is the thing that you change. We chose to change the concentration. We used 0.1, 0.08, 0.06, 0.04, 0.02 molar. Okay? We measured the absorbance. So the absorbance is your dependent variable. It's dependent upon the concentration. So we put concentration here, and you always put the unit, and then absorbance here. And what's the unit on absorbance? There isn't one, that's right, it's a trick question. Okay? So we have our graph, we started with making our graph. Now we started, the very first thing we did was zero concentration at zero absorbance. So that's actually probably a sixth point on your graph is your 0, 0. Okay? If you wanted, you didn't need to use that one because the other one should come out linear, but it helps you not have a y-intercept. So then you put your other points. Okay? And then you draw your best fit straight line through it. That's not bad. Okay? All right? So, how do we use this then? Three different ways. Number one, we measured the absorbance of our unknown. Let's just say it was right there. What do? Hang a right. Okay, sign language. Hang a right, and then what?
Go down.
Go down. That's your concentration.
Okay.
Okay? That's one. Second thing you had to do, or could have done, or you're supposed to do this too, is calculate the slope of your line. Okay? Because absorbance is equal to epsilon, path length, times the concentration, but these two things are constant, so absorbance is equal to MC. Okay? Absorbance is equal to your slope times your concentration. So if you need to get concentration, it's just absorbance divided by the slope. It's going to get you the concentration from the equation of your line, the y equals mx.
Can you email Daniel Lee and told him I was correct if he was wrong? I told him.
I'll put that in the letter of recommendation I had to do for all
Yes.
of them. Said he's a great kid, but he did give Angel the wrong answer.
And he couldn't find his lab notebook to help.
Okay, so we calculate the slope. Now here's the thing about calculating slope, is you need to pick 2 points on the line. Now, notice this point right here is not on the line. Don't use that one to calculate the slope of your line. It doesn't even have to be a data point. It can be any 2 points on the line. I always pick 0, 0 as one of them because it makes the math easier. Because then whatever, then I find one that's right on a vertice that goes right through one of the vertices of the graph paper, so I know it's exact. So I'm not guessing, I'm not having to estimate what the value is. So then I just drop down there, so then I know this is my rise and this is my run, and calculate the slope. Okay, so you should have done that manually on your graph. Okay, then once you have your manual slope, you can calculate your concentration. Third way is you have a fancy calculator. Okay,
Fancy calculator.
and you plug it in, and the calculator draws your best fit straight line for you. It gives you the y-intercept, which hopefully is near 0. It also gives you a correlation factor, which kind of gives you an idea of how close your points are to one another on the line. It's really a measure of your precision, how accurate you were with all your different values. Okay? And then use that equation, which is hopefully the two were pretty close to one another, to get your concentrations. Okay? Who had unknowns number 1 or 2? What did you guys get? You guys were cobalt.
Yes.
Yes. Who was 1?
Me and Angel were 1.
Who was 2?
Seems like I should have this. I think I know what they are.
I don't remember what I was.
I don't know.
Yesterday.
So what did we get? No one wants to say?
I got 0.015 molar.
Okay, for
Number 2.
0.015 for number 2?
Yeah.
That would have been a 3 or a 4 answer. What was it? What anybody else? Who else got a 1 and a 2? You had 3. What did you get for 3? 0.13? 0.013? Okay. Anybody who had 1 and 2? What did you get?
Not the right answer.
How do you know it?
Because it's not us. Daniel was helping me and it's.
Nobody else had unknown number 1 or 2?
I had 2. That's bad.
There is.
But but you're. Did you do it in here or in the other class?
I did the other class.
Yeah. So you did. Oh, but it's still cobalt. It's still the same unknowns.
Good luck changing.
Well, because I did copper in the first period, I did cobalt with y'all. And so,
What was your
Whatever.
position working in our equation?
I'm trying to. I know that 0.015 is one of them. I can't remember. The sheets
Let's
over
just
there.
say
say
it's 2.
I
think
got
it should be 2.
.016 for forward.
For 4, yeah, 3 and 4 were the same. 1 and 2 were the same.
What was one? What was your absorbance?
She won't say.
What was your absorbance?
Our absorbance was 0.270.
Yeah, so that she's gonna plug it in to the.
Why do you do this? At least I get half the point.
No, but what's real important on this is that you understand how to do it now, because this is a very commonly asked question as far as a lab question and different things on the AP test. They really like, because it's pretty straightforward, simple. And again, remember, this is the constant. What does B stand for? Path length, and C is the concentration, and A is gonna be your absorbance, which is, again, a measure. Now, why again now, do solutions have color?
Because they absorb some of the light.
Okay, so the electrons are moving, so from where to where? In these, okay, actually just move that over here. flying back. For these transition metals, exactly what transitions are taking place? Zane,
Is it the electron going from the s orbital to the d orbital?
which S to which D? If we're here.
They're on the top row.
I'm on in this row right here.
Sorry. 3s to d.
Where are the electrons here? Which sublevel?
S.
Which one?
4.
4s. Okay, remember there's an overlap. So you have 4s, then you have 3d. You stayed, and then right when I moved,
Sat down
you
because I was
moved.
afraid.
Okay, so we have 4s, and then all of these only have, let's just even say it's iron. It's got 6 electrons in the 3d. So there's empty spaces here, so the electrons get promoted up into those vacant spots. Okay? Now that's an excited state, that's a high energy state. Everything in nature wants to be in the lowest possible energy state. Therefore, when they naturally come back down. When they come back down to where they were before, ground state, they have to release that energy that they just absorbed, and they do that in the form of light or electromagnetic radiations. All of these elements, these all have color because of that 4s to 3d transition. So why is zinc colorless?
Because it's
It's
full.
all full.
What's full? I don't like its, I don't like pronouns.
D.
The 3D sublevel is filled, right? So there's no room for that 4s to go up, and so if it doesn't have enough energy to get to the next higher one, or even if it does go to the next higher one, when it comes down, it may not be in visible light. Okay? So it's those transitions there. So lastly, why doesn't this work for a colorless solution? Why?
There's no difference in color with concentration, so it can't measure the light.
Okay, so for those of you trying to listen, there's no difference in concentration, the color as the concentration, so the intensity of the solution doesn't change at all with concentration on a colorless solution, so absorbance won't change. So you have to, in order to use Beer's law and use a visible light spectrophotometer, you have to have a solution that has some color in it, okay? All right, does that answer the questions that many of y'all had?
I have a slightly related question.
Okay?
So, if it takes this specific wavelength of light to go from the 4s to the 3d orbital, and that absorbs that color, well, when it comes back down, shouldn't it emit that same wavelength of light?
Well, it's
Because it's the same amount of energy.
well, again, on solutions, a lot of times you have several different ones being different electrons, but I see what you're saying is why is the absorbance and the transmittance, and I don't know the answer though. I'm trying to think through that one and I don't have a good answer, so most of the time I just make something up, and I'm not going to.
So there's 0.05.
0.05? Yeah, that sounds right.
Didn't get that one.
Yeah,
Let's just-
and then, because the copper ones I made, yeah, I'll look them, I have them over there when I start the video, I'll show you, I'll get those. All right, any other questions, we're good? All right, so what we're gonna do now is we're gonna watch a video, and I'm gonna stop it periodically and talk in between, okay? This is not sleep time, okay? It is going to be one that you're gonna wanna sleep in sometimes, okay? But I personally think it's fascinating. It's the development of how our atomic theory, especially what we're focusing on, where we're going next is chapter 6 and the first half of chapter 7, which is going to be electron configurations, all the electron stuff, as well as then the periodic trends from that, okay? So 6 and the first half of 7, we won't ever do the back half of 7, because you don't need to know that, okay? Okay, they must just needed more pages for the book, okay? So, let's just watch the video, look at it from a historical background on the development, and just kind of this combination of history and science kind of coming together. All right, so you can stop it.